You know, we're all pretty used to AIs that talk. You ask ChatGPT a question, you get an answer. Simple. But what happens when they stop just talking and start doing? What if they could not only write that email for you, but actually hit send? Or not just find flight prices, but go ahead and book the ticket? That's the leap we're talking about today. The move from a single AI worker to an entire coordinated AI team.
So, here's what we're going to cover. First, we'll look at how AI's made that jump from just talking to actually taking action. Then, we'll dive into the idea of a single lone AI worker and see where it hits its limits. And that'll lead us to the main event, how we're now building and managing entire teams of AIs that work together to solve really complex problems.
All right, let's dive right in. The first step in this whole journey is understanding the fundamental shift from an AI that just generates content to one that can actually take action out in the world.
It all starts with what we know best, generative AI. You know, your classic ChatGPT. It's got this incredible brain, a large language model that's been trained on a massive slice of the internet. And it's amazing at creating stuff. But it has its limits, right? Like, its knowledge is frozen in time. It can't tell you the price of a flight tomorrow because that data didn't exist when it was being trained.
So how do we get around that problem? Well, this is where we see this really cool evolution from a thinker to a doer. You start with that same generative AI. That's the brain. But then you give that brain some hands. You give it tools like access to a flight booking website's API. And all of a sudden, it's not just a thinker anymore. It's an AI agent. It's a doer that can actually interact with the real world.
And this is the key difference. An AI agent is so much more than a chatbot. It's an autonomous system that's designed to accomplish a specific goal. You give it a task, it thinks about the steps, and then it uses its tools to get the job done. It's all about action.
Okay, so now we have our doer, our AI agent. Let's take a closer look at how this lone worker actually operates when you give it a task.
The workflow for a single agent is actually pretty simple. You give it an input, something like, hey, find me a top-rated Italian restaurant nearby that's open right now. The agent takes that, figures out what it needs to do, uses its tools to check reviews and opening times, and then boom, gives you a recommendation. It's direct, it's straightforward, and for simple tasks, it works great. I like to think of this lone worker carrying one giant backpack, and inside that backpack is everything it needs for any job it might face. It's got one huge instruction manual. That's the system prompt. It's got a list of every single tool it could possibly use, and it has a set of rules or guardrails to make sure it doesn't go off the rails. It's the whole shebang in one package. Now, this all-in-one approach sounds pretty powerful, doesn't it? But what happens when the job gets a little too big or a lot too complex for just one worker to handle?
And this leads us to the really important question. When you start scaling up the complexity of the tasks, does this lone worker model start to, fall apart? And the answer is a big yes.
And here's why it breaks down. For starters, you can just give it too many tools. Turns out the sweet spot is around 5 to 10. Any more than that, and the AI starts getting confused about which tool to use. Then, that giant instruction manual, the system prompt, just gets way too long and complicated. The overall context becomes too much for the LLM to handle. It gets totally bogged down, performance just tanks, and you start getting, well, pretty crappy results. So, if our single worker gets overwhelmed, the answer isn't to give it a bigger backpack. No. The solution is to build a team. So, what does this look like? Well, instead of one agent trying to do everything, the multi-agent approach brings in a manager. Now, this manager agent doesn't do the work itself. Its only job is to break down the big goal into smaller, bite-sized pieces and then delegate those pieces to specialist agents. It's basically the division of labor, but for AI.
So you can think of a multi-agent system as a kind of AI organization. You have a manager agent that acts like a project lead. It gets the request, figures out the game plan, and then routes the work to the right specialist sub-agent, each one with its own very focused set of skills and tools.
So the workflow goes something like this. A request comes in to the manager. The manager says, okay, first step is X, and delegates that to a specialist. That specialist does its one job and reports back. Then the manager looks at the situation and decides, are we done, or do I need to bring in another specialist for the next step? And that loop just continues until the main goal is achieved and the final answer is ready.
To make this really concrete, imagine an AI team that works as an executive assistant. The manager agent gets the request. If that request involves sending an email, it hands that task off to the communication agent. If it needs to look up some company policy, that goes to the info/retrieval agent. And for scheduling, that's a job for the calendar agent. Each specialist has its own tiny backpack with just the few tools it needs for its specific job. Much more efficient.
Okay, so we've built our team of specialists, but how do they actually work together? It's not enough just to have the players. You need a playbook, an architecture for how they're all going to collaborate.
There are a few common playbooks here. The supervisor model is what we've been talking about. One manager delegating everything. A hierarchical model is more like a corporate org chart, with managers who have their own managers. A network model is a bit of a free-for-all, where agents can talk to each other directly, but that can get chaotic. And then there's the most important one, custom. This is where you build a unique structure for a very specific problem, and that's what we're seeing most often in real-world systems.
And how do these agents actually talk to each other? Well, there are two main methods. The first is called a shared state. You can think of this like a shared whiteboard or a Google Doc, where every agent can read the latest updates and write their own notes. The second is tool calling, where one agent literally calls another agent like it was a simple tool, just passing it a specific command. It's the difference between sharing the entire project plan versus just handing over a single sticky note with one to-do item on it.
And don't just take my word for it. This quote from the team at LangChain, who are experts in this space, really hammers the point home. While all those standard architectures are good starting points, when it comes to building something that's actually robust enough for the real world, you almost always need to create a custom system tailored to your exact problem.
So, if there's one big thing to take away from all of this, it's this. The frontier of AI development is shifting. We're moving away from just trying to build a single, all-powerful AI worker, and we're moving toward designing these complex, coordinated systems of AI specialists. It's the difference between building a really good power tool and conducting an entire orchestra.
And that leaves us with one final, pretty mind-bending question to chew on. As these systems get more and more sophisticated, are we just building better AI employees? Or are we on the verge of creating entire autonomous AI organizations?